All right, so there are lots of places in the real world where people abuse tests, okay, these significance tests. And so, first and foremost, choose an appropriate significance level, okay? And you may say, what's appropriate? Well, how much evidence do you need to convince people to change their minds? If it's some belief that the earth revolves around or the sun revolves around the earth and you need people to change their minds, it might be very, very difficult to change their minds. And so you might not just say, oh, well, there's only a 5% chance that I get these results if the sun revolves around the earth. Therefore, I'm rejecting that in favor of the earth revolving around the sun. People might not believe you right away. Okay. You might want better evidence, more significantly unlikely data results. Okay. But if it's easy to change someone's mind, it's not super important, 0.05. But if it's very expensive and your company's going to have to invest a lot of money, or it's important, where you like that typo? Important. I like it. If it's very important, like sending someone to jail, you might want a very, very small probability of being wrong. Okay? Because really, the alpha rejection region is the probability that if it's true, that really you're rejecting something. You're saying, either I'm this unlucky. Well, how unlucky would you be willing to be to throw someone in jail? Hopefully, really, really small alpha. Okay. So, anyhow, statistical significance is not practical important. Okay. To be statistically significant just says we need to do further research and look. And just like in science, right, it's a consensus that changes minds where many, many experiments start to point to the same thing. And then we need to change how we think about the world based on those results. It's the same thing in statistics. When you find something is statistically significant, you say, this deserves further inspection and further study. Okay. If you don't have statistical significance, it doesn't mean that it's true. It just might mean that your sample size is too small or something. Okay. But the biggest one is called p hacking. Okay. And let's just pose this question for a second. You have 20 null hypotheses that are all true. Okay. So the claim that there are 20 fluid ounces of soda in the bottle and that there are 29 grams of sugar and that there are this and this and this, all 20 things that they claim on there are true. So you run a hypothesis test. You run 20 of them, all at the 0.05 level. What is the expected number of tests where you will reject the true null? Well, this is the probability of rejecting a true null, and this is the number. So if I do n times p, we are expected to reject one of them. And so if I'm just saying, like, is Coke honest? Well, let's test out these 20 different things at the 0.05 level. You're probably going to reject one of them, maybe two, maybe three, maybe zero. But you're probably going to reject one of them. If you do 200 hypothesis tests at the 0.05 level, you're probably going to reject 10 of them if they're all true. If you start rejecting 30, 40 of them, well, like the 10 that you reject, maybe you do those a second time with a larger sample size and see if you just had a lucky sample, because really you should have 5% of your sample should be lucky enough to reject at the 0.05 level. Okay. So if you're running many, many, many hypothesis tests, 5% of them are going to be rejected, even when they're true. So if you're running 100 of them and 5 of them come up as rejections, don't be surprised. P hacking is when you just throw everything at the wall and you just look at what sticks. Okay. You do lots and lots of hypothesis tests, you're going to reject a few. That doesn't mean that it's significant. It just means that 5% of your tests happen to be significant, just like you expect 5% of your tests to be significant. Okay. So that's uses and abuses. All right. So we'll talk more about that. Good luck and farewell.